Have you ever gazed at a towering mountain range and wondered how those dramatic, sculpted peaks and valleys came to be? What incredible forces could carve such majestic features into solid rock, leaving behind breathtaking, often symmetrical shapes? Well, many of those breathtaking formations, specifically glacial cirques and arêtes, are the masterful work of ice. A glacial cirque, sometimes called a corrie, is a deep, armchair-shaped hollow, typically found high on a mountain, often containing a small lake known as a tarn. An arête, on the other hand, is a sharp, knife-edge ridge separating to such hollows or to parallel glacial valleys. The journey of a cirque begins with snow accumulating in sheltered depressions on mountainsides, often on the leeward side away from prevailing winds. This snow compacts under its own weight, eventually transforming into dense, crystalline glacial ice. As more snow falls and accumulates year after year, the ice mass grows and begins to move, even if imperceptibly at first. This initial process, known as nivation, involves a powerful combination of both snow accumulation and intense freeze-thaw weathering. Water seeps into cracks in the rock, freezes, expands, and pries apart rock fragments, gradually enlarging the hollow. Over time, the ice becomes thick enough to exert immense pressure and develop its own slow, rotational flow. The base of this nascent glacier starts to scour the bedrock in a process called rotational scour. This action deepens and widens the hollow, giving the cirque its characteristic bowl or amphitheater shape. Furthermore, as the glacier moves, it aggressively plucks away large blocks of rock that have been loosened by those persistent freeze-thaw cycles. It also grinds against the bedrock with embedded debris, creating powerful abrasion that polishes and scores the rock surface. These combined erosional actions continually deepen, steepen, and broaden the cirque walls and floor. An arête forms when two cirques develop back-to-back on opposite sides of a mountain, or when two parallel glacial valleys erode their sides. As the ice in these adjacent features expands and retreats, the land between them is progressively narrowed and sharpened. This intense, two-sided erosion carves out the distinctive, jagged, knife-edge ridge that defines an arête. If three or more cirques erode into a central peak, they can even form a dramatic, pointed feature known as a pyramidal peak or horn, like the famous Matterhorn. Understanding this powerful geological sculpting helps you interpret mountainous landscapes. When you hike in glaciated regions, look for these telltale signs. A U-shaped valley often leads away from a cirque, indicating the path of a former glacier. The presence of an arête clearly reveals that ice once flowed on both its sides, relentlessly carving away at the mountain. Identifying these features allows you to visualize the colossal ice masses that once dominated these environments, shaping them over tens of thousands of years. These incredible landforms are not just beautiful, they are clear indicators of past climate conditions and glacial extent. The specific term nivation hollows refers to those crucial initial depressions enlarged by repeated freezing and thawing, which act as the seedbeds for eventual cirque formation. This initial ice wedge action, or cryofracturing, is a critical precursor, weakening the rock and preparing it for the larger, more powerful glacial plucking and abrasion. It is a slow, relentless geological sculptor, operating on a timescale that is difficult for us to fully grasp. So, from the humble beginnings of a perennial snow patch to the majestic, sharp features dominating high mountain ranges, glacial cirques and arêtes stand as powerful, enduring testaments to the Earth's dynamic geological past. They are vivid reminders that even the most massive and seemingly permanent landscapes are constantly being shaped and reshaped by immense natural forces, providing us with a window into our planet's icy history.